So, wanted to finish up this number 6. When we ended, we had found the positive 0 of 25, and we were looking to verify that the other 0 was indeed negative, but I realized we know that the other 0 is negative because of this product of negative 5,800. That means that my factors for this quadratic, one would have to be positive and one would have to be negative in order to get a product that's negative. So this positive 0 of 25 is indeed the only positive 0. So that's how many gift boxes she would be wrapping. All right, let's go to number 7. Suppose that the price of cable television increases 8% each year. So that's going to be 1 plus 0.08. If a household currently pays $128 a year. All right, now this, you got to think through this in a couple of ways. At first, when I read this, currently pays $128 a year, that sounds like the initial amount. But you don't just pay $128 at the start. You're going to pay that $128 by the end of the year. That's going to be your total. So that's indeed your first term. What will their payments total? That means we're going to be looking at a series. And since it's increasing by 8%, not a constant difference, but a constant ratio, this is indeed going to be a geometric series. So I'm going to use my formula S sub n equals the first term times 1 minus r to the n, all divided by the sum 1 minus r. Since we're looking at 25 years, it's going to be S sub 25 equals the first term, which is 128, times 1 minus 1.08 to the 25th, all divided by 1 minus 1.08. So go over to my calculator, and I have 12. Parentheses 1 minus in parentheses 1.08 to the 25th power. That's my numerator, and I'm going to divide that by the sum 1 minus 1.08. And that will give me my final answer. As I'm typing this in, I realized that I typed that in as a 12, not as a 128. So let's try that again. 128. I think it's because I wrote it wrong here. The first term was 128, not 12. So 128 times 1 minus 1.08. Oops. I wanted to put that 1.08 in parentheses to the 25th power. So let's make sure I type this in correctly. 128, 1 minus, in parentheses, 1.08 to the 25th. There we go. That looks a lot better. Then I'm going to divide by 1 minus 1.08. And I'm going to let you guys do that in your calculator and get an answer. I will tell you that the answer is between 9 and 10,000 total. I knew that I had done something wrong previously because I got such a low total. I knew after 25 years I'm going to have to pay a lot more than what I had gotten before, which helped me to catch my mistake. So again, my mistake before was I had written a 12 rather than a 128 here. Okay, let's go on to our next problem. A ball is dropped from a height of 60 feet. That's going to be my initial height. It's not after a bounce, it's the initial height is dropped from, and it bounces to 5/6. That's going to be my constant ratio of its previous height on each successive bounce. Use this information to answer the following. We've actually had a problem like this that we did the other day on the lesson master. And if you'll recall, we have a ball, it's dropped that 60 feet, and then it begins bouncing. And of course, with each successive bounce, it gets lower and lower and lower. And we have 12 bounces. 11, oh, one more, and that would be my final bounce. And there are my 12 bounces. And we want to know the total distance, which tells me that I'm looking at a series. Since I'm multiplying by 5, 6, this is a geometric series. I'm not decreasing by 5, 6 of a foot. I'm actually multiplying the height times 5, 6. So my formula would be 60 times 5, 6 to the n, or should it be n minus 1? That's what we need to think about. Since this is the initial height, then this is n. If this was the first bounce, this would be n minus 1. So s sub 12, because I've got 12 bounces, is the first bounce, which means I need to find the first bounce. I need to figure out 60 times 5, 6 to the first, and figure out what that first bounce would be. 60 times 5, 6. Well, to the first, I know that's just times 5, 6, is 50. So 50 is going to be that first bounce. 1 minus 5 sixths to the 12th, all divided by 1 minus 5 sixths. Now I know 1 minus 5 sixths is simply 1 sixth, so I'm just going to put that as my denominator. Alright, so I get to my calculator and I do 50. 1 minus, in parentheses, 5 sixths to the 12th. And I divide that by 1 sixth, and I get 266.35 feet. Now that is for 12 bounces, but that means this is the first, second, third, fourth, 5th, 6th, 7th, 8, 9, 10, 11, 12. But what I haven't done yet, I haven't accounted for this extra 60 feet. I also haven't realized that when it goes up, it has to come back down. So on every one of these, I have this distance, but I also have this distance. So I need to double this amount and get a number. And then I need to remember to add my 60 feet. So I need to double this number, and I need to add my 60 feet in order to get my total. Part B is if we had done infinite series, and we did not, so you do not need to answer question B. Let's go on to number 9. Consider this geometric sequence. They've already told us that it's geometric. Determine the 44th term in the sequence. So I need to write a formula. So G sub n equals the first term, 68. I need to figure out what my constant ratio is, and it would be to the n minus 1. Since this is term 1, my exponent is going to be n minus 1. In order to find my constant ratio, I take term divided by previous term. So 1.5. And I can test that to make sure. 153 divided by 102, also 1.5. So yes, that is my constant ratio. So determine the 44th term. So G sub 44 is going to be 68 times 1.5 to the 43rd power, because 44 minus 1 is 43. Put that in my calculator, and I'll get my answer. Let's look at letter B. It says determine the position of this term. So we want to find n. Well, so I need to figure out, how do I get 19,851.1897 to equal 68 times 1.5 to the n minus 1? This is the answer that I want. So I'm going to go to my calculator and type this formula into y equals. And I do need to put parentheses around this x minus 1, like that. to show that this is, I don't want it to be to the x and then subtract 1. I need to make sure I protect that exponent with parentheses. And then I'm going to go to my table. And I need to look for this answer. Let's see. Oh, around 19,000. Scrolling. Oh, look, there it is right there, 19,851. Let's see if when I go to that, look, it actually shows me that it's 0.189. That would be 1897. So if you actually click on the number, it shows you what the full number is, and it is indeed that number. So it's the 15th term. I'm not going to actually write that down. I'd like you guys to have to watch this and not be able to just fast forward in the video. I'd like you to have to look for it here and see that it's the 15th term and write that down there. All right, our very last problem. A new business decides to rank its 12 employees by how well they work and pay their salaries according to this. The company has a total amount. So wait, first we have 12 employees and we have a total amount of $433,200 to spend in salaries and plans to have the difference between each employee's salary be $700. So this sounds arithmetic because there's a constant difference of $700. How much will the lowest and highest paid employees be making? All right, so I'm thinking this is a total amount, so it's going to be an arithmetic series. So I'm going to use my formula, S sub n equals n divided by 2, 2 times the first term, because I don't know what that initial salary is, plus the constant difference, times n minus 1. I know my total, 433,200. I know that I have 12 employees, so 12 divided by 2. 2 times, I don't know what that initial salary is. I do know that the constant difference is 700. And n is 12, so 12 minus 1 is 11. So I just have an algebraic equation to solve here. So I'm going to start simplifying. This becomes 6. I still have 2a to the first plus 11 times 700 would be 7,700. Then I'm going to distribute my 6. Let's see what that would be. 6 times 7,700, 46,200. And I'm going to let you guys solve that the rest of the way for the first term. Once you find that first term, that's what you're going to find right here. You know that that's the lowest salary. And then you can use your formula to find the highest salary. You can write a formula, a sub n equals the first term, which is what you found right here, plus 700 times n minus 1. And you know the highest salary has to be the 12th person, the last person. So you'll put whatever that amount is that you got for the first term, plus 700 times 11, and you'll be able to find the salary for the last person. So the first salary is the lowest. Then you're going to use that to write your formula, and then you can use that to find the 12th term for the highest one. Now, I will tell you the ones we did on this page are a lot more challenging, but if you can do these, you are going to have no problem with the ones on the quiz.